In the intelligence community, we understand that the world is a dangerous place. And dangerous is the new normal. Historically, as a community, we focused on traditional threats from state actors, analyzing conventional forces and technical capabilities, as well as their intents. Now, we've adjusted to a multipolar world with a broad array of threats from state and non-state actors, covering national security, terrorism, geopolitics, environment, finance, and public health. But often, our response to threats has been reactive. We tend to minimize risk or avoid it altogether. But now we're ready for a new approach, one that embraces risks and even plans for it. We know risks are constant, so we can now identify risk indicators, plan our responses, and use tools and technologies to scan the environment for these risk indicators, check for threats, and monitor that environment in real time.
All right, thanks, Kurt. Next slide. So the open data revolution. Open data is the idea that data should be free, transparent, and free to the public and accessible. No need to pay anyone or go through any locked doors to use. Users are contributing open data like they never have before through volunteer geographic information, using portals like OpenStreetMap, Wikimapia, through geotagged content such as tweets, Instagrams, Facebook posts, or through GPS breadcrumbs generated by mobile devices, such as my smartband right here. I can map my route or map untracked paths and then upload them onto a Wikimapia or OSM and contribute to the open source content. APIs are out there that are allowing people to harvest all this user-generated content. And some examples are, as you've seen, the Twitter streaming API, another one's the Instagram API, Facebook API. So all these methods have, all these techniques have methods for accessing geotagged information. So we're going to move on to our tech stack. Some of the code and how it's actually done, you guys can see. We use two methods to mine open data from the web. First one is the GDELT project, and the second one is Tweepy. So the GDELT project on the left is an initiative to mine news and media feeds from 1979 onward to catalog the events, actors, locations, and sentiments of the world over time. It's a pretty audacious project. The database is massive, 250 million rows and 59 fields. So we use Google BigQuery to query out the data. It allows SQL calls to the REST service. And the responses can just be saved as a regular CSV. In this example, we've mapped out the GDELT points as black dots and built a kernel density map to represent foreign aid over China. And we set this to download the data for December 2015. And so you guys can see a cluster of points right over Shanghai. That's where that exists. And fields such as average tone can be used to show positive or negative sentiments for each article. Tweepy, on the right, is our second example. It's an open source Python wrapper around the Twitter APIs, hosted on GitHub. And it can be used to crowdsource tweets in real time. In this example, I created a listener to listen for tweets, and we filtered for tweets on January 22nd, 2016, having a geotag and containing the words winter, snow, and storm over a 1-hour period. And so, as you all remember, this was Winter Storm Jonas that hit the East Coast. And so the JSON responses and geotags are shown. I've marked them out, and this gives you a real-time feed into what sentiments are happening all over the globe and when. So how can all this free and open source data technology be used to identify risks and threats? And I'll move on to Matt, and you can move on to the next slide.
Thanks, John. Well, whether organizations are in charge of multiple pieces of infrastructure or just one, understanding and managing risk is critical. As previous presenters have shown, agencies like the CDC and World Health Organization provide data that can be layered with open source and social data feeds to monitor activities surrounding critical infrastructure, such as an airport or a seaport. Using historic data is a great way to help predict where and what threats may be present. However, by using a holistic approach and layering historic data with real-time data, an organization will better know how and where to deploy its resources during a crisis event. In order to do this, we hold workshops with the client, not just high-level stakeholders, but all members from every level within the organization, where we help them understand the variables, identify the variables, and understand them, so they can influence the risks so they can find out which risks are facing the organization. They use the social data miners, like John was just mentioning, to help capture those variables and understand the stability surrounding those critical infrastructure and respond and monitor those incidents. Ebola, the Zika virus, and whatever else is next, the global network are a hub for which pandemics can spread easily. The global network of airports are a hub for which pandemics can spread easily. The Department of State manages about 25,000 assets, each of which is critical to its mission. In order for agencies like the State Department and DHS to monitor these risks against these assets, they need to use every tool available to them. Mobile data networks are proliferating in developing countries, and this creates opportunity to provide valuable insight. By using all the available tools, an organization has the ability to anticipate and the spread of pandemics and respond accordingly when they are monitored effectively. Next slide, please. This is the end of our presentation. Thank you for listening. If you guys would like to find us out on the floor later, we'd be happy to answer any of your questions. Thank you very much.
All right. Thank you.